at the solution itself and how we design it. So this is in your text, this is number 34. And if I look at this, it's going to follow the same format that all of them have followed so far, in that we have our decision variables up top. You know, this goes through C4 through H4. We are using some product all along column I. You see the first two constraints, the present worth, the programmers, the budget, and then I think we did these right. Project 4 when project 5 together, project 2 only if project 1. So they did it a little bit. We did x1 minus x2 is greater than or equal to 0. They did a little bit different. They said negative x1 plus x2 is less than or equal to 0. Algebraically, it's the same thing. I like my formulation better, right? Because x1 minus, algebraically, it does the same thing and would do the same thing, but I like mine. Mine's a little more straightforward. Not both project 3 and 6, same way we have it, 3 plus 6, less than or equal to 1, and no more than 3 projects. Add them all up, and it has to be less than 3. If we look at the solver for this, all of this looks the same except for this constraint. Okay, this is nothing new in here except for this constraint where we say all of these decision variables, C4 through H4, and we come down in the drop down and say binary. Okay, that forces them to be binary. When I solve this, okay, it found a solution. Well, let's go back. That's not what I wanted. The solution that it came up with is do projects 1, 2, and 6. That ends up giving us a present worth of 11.8 million. We end up using 58 programmers of our 60, 3.3 million. Looks like we do neither 4 nor 5. It looks like we do both project 1 and 2. It looks like we do project 6 but not project 3, so we're okay there. And we do projects 1, 2, and 6. So that's 3 projects. And I know this one up here says 1.1 e to negative 13. What that's really saying is what? That represents what? 0, right? It's 0.00000000011. Just Excel doesn't arrive at a perfect 0. It's going through a formulation. But that really means 1, okay? So any questions on that? Okay, any questions on that? Yes, no? Do you guys understand those constraints? Because that is tricky. With the binary, it is tricky. There is one like that on the in-class, okay, where it's a project selection model. There'll be 4 or 5 projects. We're going to be maximizing net present value, because I think that's common. You know, there's going to be cost constraints. There'll be, I think there's a labor constraint. And there's going to be some of these kind of combination things as well. So that one is a good one to review for the in-class midterm exam. Questions?
Is that up on Blackboard, like the solution?
Yeah, all solutions are on Blackboard. So if you go to, you know, this is chapter 3. You'll see like the PowerPoints, but also under there, you know, you'll see all the solution Excel files. Okay. So all the solutions are included. And I did forget to record at the beginning of this, but if you want to go back to 2014 or 2013, you can probably hear my explanation 2 years ago, which was probably the same damn thing or better, because I was younger. Okay. So any questions on that? All right, the other one that I specifically wanted to look at, and you guys can choose any others that you like, was 28. Did I assign 28? Yeah? Okay. Okay. Now, 28 belongs to a family of models called staffing models. And if anyone ever had to, staff something, a restaurant or an exercise, or, even I staff, I do the undergraduate schedule for school of business. Nicole does the graduate schedule. So we both kind of staff those classes, right? Understand that that's a difficult exercise because you have all kind of constraints, right? I have only so many sections from the registrar's office where I can offer classes. I only have so many faculty to teach those classes, right? They have not limited, but they only have expertise in certain disciplines, right? We have so many students that need these subjects, so we need to offer so many things. Think about that. That's all kinds of constraints. I try to come out with the best schedule that we can, right? But we have all kinds of constraints. So even when I staff like a restaurant or anything like that, I also have all these constraints, right? I have different people working different shifts. I want these people with these requirements here at certain times. But when I look at it, when I'm managing a restaurant or something that's service-oriented, one of the things I probably want to optimize is I probably want to minimize my costs, right? I want to minimize that people are an expensive resource to any kind of service organization. So we're trying to minimize cost here. So let's look at number 28. And this one's, it's not a great formulation. It's not a perfect staffing model. But it gives us an idea of what they might look like. So we are working at Burger Boy Restaurant, and it's open from 8 a.m. to 10 p.m. daily. In addition to the hours of business, a crew of workers must arrive 1 hour early to help set up the restaurant for the day's operations, and another crew of workers must stay 1 hour after. So it looks like we're open from 7 a.m. to 11 p.m. That's when we need to staff this thing. Burger Boy operates with 9 different shifts. So there's people that start on shift 1. If they work on shift 1, they work from 7 a.m. to 9 a.m. They are part-time people, and we give them $15. So they work 2 hours, we give them $15, $7.50 an hour, I guess. If they start on shift 2, they work the whole morning, 7 a.m. to 11 a.m. They are part-time employees, and we give them $25 for 4 hours, so that's $6.25. That's below minimum wage. We're violating federal laws at this point. From 7 a.m. to 3 p.m., these people are full-time employees. We give them $52 a day. And then in shift 4, 11 a.m. to 3 p.m., these are part-time employees. Okay, you guys get the gist. So we have 8 shifts, basically, 9 shifts it looks like. And these people are either full-time or part-time. And we have here how much we pay them. We also know, we have some needs. So a needs assessment study has been completed, which divide the workday at Burger Boy into 8 2-hour blocks based on our traffic, our customer traffic. The number of employees needed for each block is as follows. From 7 a.m. to 9 a.m. we need 8 employees. From 9 a.m. to 11 we need 10. 11 to 1 we need 22, so forth and so on. So I'm going to ask you the same 3 questions that I always ask. I want to ask you, okay, what are we deciding here at Burger Boy? What are we deciding at Burger Boy? What are my decision variables? It's a staffing model. So what am I deciding? Go ahead, Stephanie. Yeah, I'm deciding, I have 9 shifts. How many people are going to work each of those shifts? Like how many people to start at shift 1? How many people to start at shift 2? So my decision variables are X1 through X9. So X1 is the number of people to start on shift 1. Those are the 7 a.m. to 9 a.m. part-time people. How many people to start on shift 2? Those are the 7 a.m. to 11 a.m. part-time people. Shift 3, they're the 7 a.m. to 3 p.m. full-time people, right? Okay, very good. How many people to start on each of those shifts, right? That's what I'm trying to decide. What am I trying to minimize or maximize here? What do you think I'm trying to minimize or maximize? Yeah, I'm trying to minimize my salary, my daily salary expense, right, Adam? So I'm trying to minimize, if I hire one person on X1, how much does that cost me in a day? 15, right? 2 people, $30. 3 people, 45. So 15 X1 plus 25 X2 plus, and the whole way down to 16 X9. So there's my part 1, part 2. By the way, can I hire 1.65 people on a shift? No, so all these things are going to be integers, right? Not binary, but integers because they're counting numbers. 0, 1, 2, so these are integers. Might as well write that down, okay? All right, so we need to staff this thing, right? We need at least 8 people here from 7 a.m. to 9 a.m. That sounds like a constraint. Greater than or equal to 8. Subject to. So who's here from 7 a.m. to 9 a.m.? Of my shifts up there, which people are here from 7 a.m. to 9 a.m.? Okay, the people that start on shift 1 are here, right? Because they're here from 7 a.m. to 9 a.m. only. How about, who else is here from 7 a.m. to 9 a.m.? Yeah, shift 2, they're here from 7 a.m. to 11 a.m., so they're here, right? And shift 3. So the combination of those 3 shifts has to be greater than or equal to 8, right? It doesn't say has to be 7. It says of that 2-hour block, who's here? Well, X1 people were here, X2 people were here, X3 people were here. It says from 9 a.m. to 11 a.m. I need 10 people. Okay, during that 2-hour block, I need 10 people. Let's see who's here. Well, the 2 people are here, right? The shift 2 people are here. The shift 3 people are here. I think that's it. Is that it? So X2 plus X3 has to be greater than or equal to 10. Let's see. From 11 a.m. to 1 p.m. Wow, I need 22 people. That's, I guess, the lunch rush hour. Well, who's here from 11 a.m. to 2 p.m.? It looks like the shift 3 people are here, shift 4 people, and shift 5. So X3 plus X4 plus X5 is greater than or equal to 22. Now, I'm not going to go through it, but I'd have to do that for each of those 2-hour blocks. Does that make sense? I'd have to say, hey, I need 18 people. Who's here? What shifts are here during that time? And the sum of those shifts has to add to at least that amount. Does this make sense? So I would have a constraint for, 1, 2, 3, 4, what's that? 3, 5 more. I'd have 5 more constraints that I'm not going to do. But that's not all at Burger Boy. They also want at least 40%. Wants at least 40% of all employees at the peak time periods of 11 a.m. to 1 p.m. and 5 p.m. to 7 p.m. to be full-time employees. At least 2 full-time employees must be on duty when the restaurant opens and when it closes at 11 p.m. Formulate and solve a model Burger Boy can use. Okay. So a couple ones are easy, right? We need at least 2 full-time employees at 7 a.m. and 11 p.m. So let's look at that first. Okay, that's the easy one. So we need at least 2 full-time employees at 7 a.m. to at 7 a.m. when it opens. Is that what it said? Yeah, we need 2 full-time employees at 7 a.m. Who's here at 7 a.m. that's full-time? Only who? Only the X3 folks, right? So X3 has to be greater than or equal to 2. Okay. We need two people here, two full-time people here at 11 p.m. when it closes. Well, who's the full-time people that are here at 7 p.m. when it closes? It looks like just the X7 folks, right? So X7 is greater than or equal to 2. Now here's the hard one, and well, there's two of them here. It says Burger Boy wants at least 40% of employees at the peak time periods of 11 a.m. to 1 p.m. to be full-time employees. Let's handle that one first, okay? So from 11 a.m. to 1 p.m., we want to make sure that 40% of the people here are full-time folks. Well, first, who's here from 11 a.m. to 1 p.m.? Well, the X4s are here, right? Well, actually more than that. The 3s are here, right? But they're part-time. The 4s are here, or I'm sorry, the 3s are here, they're full-time. The 4s are part-time, and the 5s are full-time. So from 11 a.m. to 1 p.m., those are the three groups of shift people that are here, right? Did I miss anyone? No? Okay. But I don't know how many I'm hiring on those three shifts. But I want to make sure that at least 40% of them are full-time people. So what does that sound like I might need? I might need a summation variable. What we could do, Adam, is we could say, and I'll kind of do up here because I'm getting kind of low here. I could say x3 plus x4 plus x5. That's all the people here from 11 a.m. to 1 p.m. minus x10 is equal to 0. That creates a summation variable. x10 is the people here, right? The people here from 11 a.m. to 1 p.m. Now, who's here that's full-time from 11 a.m. to 1 p.m.? Looks like the 3s are full-time and the 5s are full-time, yes? So x3 plus x5, folks, better be greater than or equal to 40% of all the folks here from 11 a.m. to 1 p.m. And that's what x10 represents, all the folks here. Does that make sense? So minus 0.4 x10 greater than or equal to 0. Now that's one way to do it with summation variables. But your book doesn't do it with summation variables. What your book says is, okay, I know x3 plus x5 has to be greater than or equal to 40% of the total that are here at that time, which is x3 plus x4 plus x5. But it then simplifies this. So what do we have to do to simplify it? Well, we'll carry through the 0.4. So we have x3 plus x5 is greater than or equal to 0.4 x3 plus 0.4 x4 plus 0.4 x5. And I need to get a 0 over here, right? So what do I have to do to get rid of all this? Subtract that from this side. So 1x3 minus 0.4 x3 is 0.6 x3. There's no x4 here, so minus 0.4 x4 gives me 0.4 x4 negative plus 0.6 x5 greater than or equal to 0. So this one constraint means the same as those first two I wrote, okay? I know that got hairy quick, right? But that's a summation variable. I can also do it with Excel by using the sum, okay? But there's two ways to do that. With the summation variable, just algebraically to gut it out, or also to use the sum function in Excel. All right. Let's take a look at this one on Excel. So if we look, okay, it has 9 decision variables, okay, exactly what we have. They're all integers, you notice, counting numbers. Our daily cost is what we're minimizing. These first 8 constraints are all the constraints that we're saying, here's the minimum we have to have. Here's the one open, we have 2 full-time employees when we open, 2 full-time employees when we close. And then here's the constraint I just wrote for between 11 and 1, we have to have at least 40% full-time. I didn't do the one yet because it's the same damn logic. For the one we close, we have to have 40% full-time there as well. Okay. So if I look at this solver-wise, everything's pretty much the same as we've been doing it, but the difference is that we have to set a constraint that says all our decision variables are integers. And it's in the drop-down, instead of saying int, I need this, or instead of saying bin for binary, I need to say int for integer. The one where you'll have to do this on the take-home is the physician one, right? If you guys have started, there's, I think the third one, maybe the fourth one, talks about physician assistants and nurse practitioners and something else, I don't know, I can't remember. But that's a staffing, well, it's not really a staffing model, but it definitely needs the integer constraint, okay? You guys have done that. Those are the 2 from the homework I definitely wanted to do, okay? Because I think those are unique enough that they bear going over. But were there others from the homework that you wanted to talk about? All right, then before we go into the new material, we have about 20, 25 minutes before the break. What questions might you have on the take-home exam, for those of you that have started the take-home exam? Are there any questions on the take-home exam? Jordan?
If we've started it, did you say last week that we could bring it to you, you'll check over it a little bit, let us know?
Yeah, if you, especially like now, if you started it and have questions now, I'd love to hear those questions now. Because if you have a question now, and I answer it now, the benefit of everyone hearing that answer is even better. Does anyone have, so, but yes, if you have questions, I will help you with those, yes.
The first question.
Yeah.
Part B. What constraints are binding?
Okay, let's look at that. Okay. So we go to take-home exams. We go to the midterm exam. And midterm take-home due next week. Okay. So Chin asked, what constraints are binding? Okay, well, so you set this up, you solve it, you keep the sensitivity report, and part B says, what constraints are binding? How do we know something is binding? How do we know something is binding? When we look at a solution or the sensitivity report, there's 2 things that tell us it's binding. What is one of those things that tells us it's binding? Yeah, Adam?
Under the solution, when your constraint equals the value that you entered that formula in.
Yeah. Okay. So when it's solved with equality, for example, what he's saying is, let's say I had 60 programmers. I know this didn't work out that way, but if I had 60 programmers and I used all 60 programmers, that's something that's binding. That's holding me back. Do you know what I mean? Like, I don't know if you remember the Mary's Bakery one. I used all the eggs, right? I had 500 eggs. I used all 500 eggs. That's telling me that's holding me back. So usually things that are binding, when I look at the sensitivity report, what do they also have with it? If we used all of them, what do they have with it that tells us, hey, if we acquired more of this thing, our profit would go up by this? What value is that? It's the shadow price. So if you look at this one, okay, this is a production mix, right? So if you look at this one, what the hell are we making here? Tennis rackets, okay? What are we making? Big and small ones or something? Standard and oversized, right? So the things that are holding us back maybe could be our production time, We probably have some kind of special alloy here, it looks like, yes. So which of those things are binding? Which of those things are solved? So we have 100 kilograms of this special alloy. If we used all 100 kilograms of that, I'm not sure if we did, but if we did, that's binding. We have 80 hours of manufacturing time. If we used all 80 hours of that time, that's binding. Okay, does that make sense? Okay, especially when you do this one, make sure you're careful. The coefficients for rackets, oversized and standard, is in minutes, but our manufacturing time is in hours. So don't mix those, right? Put them either both in minutes or both in hours. Probably easier to put it in minutes. So 80 hours times 60 gives me 4,800 minutes. Okay. Good question. And then when I say interpret at least one shadow price, what I'm asking you to do there is in your own words, okay? Nothing, it doesn't have to be like, hey, this is exactly how Dr. Miko said in class, because I probably never say it the same way twice. In your own words, I want you to say, what does this mean? Okay, the shadow price is 20 cents. What does this mean? I want you to tell me, hey, for every unit increase I get of alloy, perhaps, my profit will go up by 20 cents. That's all. Or every unit decrease of this alloy, my profit will go down by 20 cents. And if you want to get advanced, you can throw that range of feasibility in there as well. Okay, but that's what I'm looking for. A sentence explaining to me that you know what the hell the shadow price is, basically. Okay. Any other questions? I got a question today about 36, so I might as well answer that for the whole class. It says parts A and B only on page 180 of our textbook. Those are two separate models, okay? They're the same situation, but it's two separate models. In the part A, I can't remember exactly how it went, but in one part, we're saying we need to get this many exposures, minimize the cost to get this many exposures. The second one, we're saying, hey, maximize exposures, and we got to adhere to this cost, okay? So it's the same situation, but we look at it differently. So you have to, change it. One thing's going to go in the constraints, one thing's going to go in the optimization function. The thing that we have to have, the thing we have to adhere to, goes in the constraints. The thing that we want to optimize goes in the objective function. All right. Other questions? Yes, Jeremy.
For that one,
Yeah.
you can get like half of an ad.
Yeah, that's fine. Yeah, that's a great question there. I think that one, you might say, well, why don't we do that as an integer constraint? Well, it's probably, you could, but I would probably recommend not doing it as an integer constraint. I know you can't run like half of a newspaper ad or half of a TV commercial, but we're going to say, because there's so many ads we're running, like 200, we're going to say it's minimal. So we're just going to say you don't have to make those an integer. You can if you want, but I wouldn't make it an integer. Okay? You could if you want. But when we do an integer, we lose our sensitivity report. So we avoid that if we can. All right. But I think the one answer actually is half an ad, right? If you have a half an ad, then you solve it. All right. That's probably right.
That's what I'm asking.
Yeah, it's probably right. Was it 62 and a half? You're right. Turn it in. Other questions? Yes?
Do you only use the total when you're working with the integer and the binary? Or
What total you
like
mean?
the total as part of the sum product type format?
You mean are you talking like a summation variable?
Yeah.
Yeah, the only time we use a summation variable is not necessarily just when we have integer and binary, okay? We've been doing that with integer and binaries because we kind of introduced them at the same time. But you can use summation variables with just regular ones that aren't integer and binary. Of the ones we're looking at here, okay, this one definitely needs its integer, and it definitely needs a summation variable, right? Number 3 is integer, and it definitely needs a summation variable because it says, to that end, they want at least 40% of its staff to be physicians. Excuse me. We don't know how much the staff is, so we have to create a summation variable or total for the staff, and then write a constraint based on that. As well, neither nurse practitioners nor physician assistants should account for more than 40% of total staff. That one, don't let it confuse you. That's two separate constraints. We're going to have a constraint that says nurse practitioners has to be less than or equal to 40%, and then another constraint that says PAs have to be less than or equal to 40%. So you're going to have three summation variable constraints here. Okay. The last one as well is going to have, number 4, is also going to have summation variables because I'm mixing together all this wine and fruit juice and cooler to make the rosé wine, to make these wine coolers, and we have these taste specification requirements. The wine cooler must consist of at least 50% white wine. I don't know how much wine I'm making, so that's going to be based on a summation variable, right? 50% of the total. It also says at least 20% and no more than 30% rosé. This is two constraints because one constraint is going to say has to be greater than or equal to 20%, and another constraint is going to say has to be less than or equal to 30%. Because we want it to be in that window, right? Somewhere in that 20 to 30% range. And the format of this, I think I may have told you guys, I'm not concerned with beauty in this case. You know, it doesn't have to be, you know, bound. It doesn't have to have like a certain staple on it, or I mean, you know, do something you're proud of. But I'm not concerned. You know, if you use 3 different colors pens, that's fine. You know, as long as I have the content to answer the questions. I know this isn't something. You know, your group project, maybe the form's a little more important because you're presenting it to the class as if you're presenting it to, you know, a group of decision makers. But in this case, I just want the content, okay? It could be like notebook paper stapled to Excel spreadsheets, that's fine. Clipped, stapled. Yes, Eric?
Also for number 4, another question, what are you looking for as the goal? Whether is it trying to minimize the cost, or you have the how much you can make per gallon, so is that maximizing?
That's a great question, and the answer to that is yes. Because it's both, right? I'm not trying to be funny here, but it's both, right? If we're trying to maximize profit, how do we maximize profit? By minimizing costs, right? So we can look at this a couple different ways, okay? And people have done this a couple different ways and come up with the same answer. You're going to come up with the same answer. The way I think that makes most sense to me, but it seems to confuse students, so I'll explain that way first, and then you'll see if it makes sense to you, then I'll explain the other way. The one way we can look at it is, if you think about it, all right, this whole mixture at the end, right, this whole big mixture at the end is wine cooler, right? The whole, say it's millions of gallons, it's wine cooler. And we sell that whole thing for $2.50 a gallon, right? That $1 million. So if you think about it, in that, you know, millions of dollars of wine cooler, there may be, I don't know, 10,000 gallons of fruit juice. Well, fruit juice cost us, I can't remember, let's say it cost us 50 cents per gallon, right? So every gallon of fruit juice I used, which gets all mixed in there, how much did each gallon contribute to my profit? If I paid 50 cents for it, but when it gets all mixed in, I charge $2.50 per gallon. So how much did it add to profit? Cost 50 cents, but when it came out, we charged $2.50 because it's all mixed together. How much did I make for every gallon of fruit juice? $2.50 was the charge, cost 50 cents going in, $2. That's the profit contribution of that. So I can just say, if I want, I can maximize $2 times how much fruit juice I use plus $1.50 for the white wine and $1 for the rosé, because the white wine cost me $1, but I'm going to charge $2.50 when it comes out the other end because it's all mixed in, right? The whole mixture charges $2.50. So you can look at it that way. The other way you could do it is you could have a total, right? The total mixture. And it's $2.50, so let's say that's X4, that's your total. That's $2.50, okay? And then you could say minus 50% for every gallon of fruit juice. 50 cents minus $1 for every gallon of what was that? White wine. Okay, minus $1. That's another way you can look at it. Both of those ways will come out to the exact same answer, I guarantee. Okay, but it depends on what makes most sense to you. I'm trying to decide how much of each product to mix in to maximize my profit. But I have to meet those taste specifications. That mixture, I have to adhere to that mixture. Don't try to add that mixture into the objective function. Keep that separate. The mixture is all taken care of in the constraints. Don't try, I've seen students try to do that. They try to say like, well, 250 and it's 20% this, so it's about, no. That's all in the constraint section. That mixture, don't even think about that when you're thinking about the profit margin. Okay? Does that help? Good. All right. Any other questions? All right. Well, I gotta go drink a water, and then we'll come back and we're gonna talk about chapter 4. Now, chapter 4, some of the concepts we talk about in chapter 4 will be on the midterm in class, but no problems from chapter 4 because I don't think it's fair for me to give it to you this week and then test you on it next week. So no problems from chapter 4, but some of the concepts we talk about will be on the midterm exam, okay? So that's called network models, and you'll see it's kind of related to what we're doing now, all right? So take like a 15-minute break, come back, and we'll start chapter 4.